Kongunadu College of Engineering and Technology, Department of EEE, subject name Power System Operation and Control. Title name is Load Frequency Dynamics of Single Area System. Next, what are the basics option to open a MATLAB software? Open a MATLAB window and go to home page, open a new script, type your program, save program for using M file, go to editor menu and then run the program. Error is occur, indicate red line for command window. If not error means we are going to get the output value. Aim the steady state the time response of area frequency deviation following single load change in a single area power system provide with an integral frequency control. Next case 2, to study the time response of area frequency deviation and net interchange deviation following a small load change in any one of areas of interconnected two area power systems. Next, how to open a MATLAB simulating software for a procedure. Click MATLAB window and open a model file for a simulating library and click required component, drag and place one by one for a new model file. So connect them and enter the data to form the model of given single area power system. Save and run the model to view the output is scope. Repeat the same procedures for the given two area power system model. So this diagram is a single area system. First one is sum, second one governing system, the third one turbine system. The turbine output is given to the sum, and then this one of the feedback signal is to delta, that means maximum power demand, and then turbine signal is given to the power system, that is called a generator. The generate output we are going to get the scope signal. So once you have to click the scope, we can get the output value. Again this one is a comparator to compare the input signal and as well as the output side, that is called a feedback signals. So the software required MATLAB simulating software. So these are all the formula to study the turbine function, governor function and the power system transfer function. The turbine system is 1 by 1 plus STD, governor transfer function means 1 plus STH, then power system transfer function 1 by 1 plus STP. So here steady state frequency del omega s is equal to del PD divided by 1 plus R 1 by R plus T. So this system is going to be used for the form. This is single area load frequency control diagram, simulating diagram. First we can draw the simulating, next governor control, third one turbine, and fourth one sum of the operation, last one power system, and finally we can get the scope. In this scope we are going to get the output value for this given system. So in this MATLAB software we are going to open a MATLAB and opening a Simulink. So once this click the Simulink means it will be installation for Simulink block diagram, that is the components we are going to get the worksheet side. So this Simulink is very important. So next you can click this Simulink. So Simulink means once this we can get this kind of areas. After that we are going to the menu for file, edit, view, display, diagram, simulations. So you can click this simulation. Again it will be installing for this Simulink. So this kind of block diagrams we are going to get it from this Simulink software. So we have to using for these block diagram reductions, we can get the one by one and go to connect these systems. So first using for this scope function, SCOPE, it is called a scope function. So we can get the block diagram or the symbol means here. The scope is we are receiving scope. So just you can track this symbol and for this workplace. So this kind of track can get. Next another one, scope. So this scope is again we are going to track. After that so what are the diagram it will be needed. So here one is for the comparator. So again the comparator we are going to using. Next for this type this menu you can get collect the comparator. Just you have to type one by one and get this value. That means Simulink block diagram. Next control system toolbox means we can get this Kalman filter one. So after that sources we no need to use for any sources because the generating station is generate the electrical power with the input sources of coal based power plant or thermal based power plant or nuclear based power plants. Next is sink. So these kind of block diagrams you are going to get and open for this new one. So we can get this next this power system, turbine, governor and sum we are going to collect the Simulink block diagrams. Again it will be going for this Simulink block diagram. You can type this governor. So likewise you have to collect all the data and step by step. After we are going to connect these systems. So finally we can get this output for this system, Simulink output single area system. For this system frequency deviation versus time. So time is 4%, maximum power demand is 1000 megawatts. After that another one diagram. So now we change in turbine power deviation time. The percentage of 4 means the maximum demand is 1000 megawatts. So next two area system. So the two area system means we are going to draw the same diagram for two times. It will be connected for the parallel connections one to boost the power supply or increase the supply voltage and maintain the constant frequencies. So this is the output of two area systems. Two area system output change in frequency deviation versus time. So the next one, change in frequency deviation versus time, area 2, because of single area system 1 and single area system 2. So these are all the output value we can receive this given block diagram reduction method. So after Viva questions, so finally we have to write this result. For this the time response of both single and two area systems we have studied and the result we are using verified for the MATLAB Simulink softwares.